Mr. Hassan's Maths channel, and I'm now going to answer question number 2 from the May-June 2005 Pure Mathematics P1 paper from Cambridge 9709. And this is a question which is also, I think, question number 2 in one of my Test Your Understanding pages at the end of one of my chapters, one of my units. And this question is about finding the gradient of the curve y equals 12 over x squared minus 4x at the point where x equals 2. So we want to find the gradient of a curve. So when we're finding the gradient of a curve, we have to think about the gradient function. The gradient function is found by differentiating the original function. So we got to find what dy dx is. Okay, before we find what dy dx is, we have to prepare this to be differentiated. So any x terms not in the denominator must be written in the numerator. So I'm going to write this as 12 times. I'll write this as x squared minus 4x to the power of negative 1. Okay, now this is in a form that I can now differentiate. And in order for me to differentiate this, I have to use the chain rule. Okay, so to use the chain rule, I multiply by the power, so I get minus 12 times. Then I take one from the power. So I take one from the main power, which is here, so it's going to become negative 2. And then I multiply by the differential of what's inside the function. You always differentiate by the differential of what's inside the function. This is called using the chain rule. Okay, so you always multiply by this function, which is inside the main function. Okay, so this gives you 2x minus 4. All right, so if you simplify this, you're going to get minus 12 times 2x minus 4, and this bracket I can write in the denominator as x squared minus 4x to the power of positive 2. So this is your gradient function. So this will tell us the gradient of our function at any point we need to know it. We could simplify this further. We can take out a common factor here and stuff, but no need to do this. We just have to now find what dy dx is when x equals 3. When x equals 3, so we replace the x with 3. So you have minus 12 times 2 times 3 minus 4 over 3 squared minus 4 times 3 all squared. Okay, so this is going to give you negative 12, 6 minus 4, which is 2, over, that's been 9 minus 12, which is negative 3, but that's going to be squared. 9 minus 12 squared. So this is going to get here, I'll leave it like this because we might be able to cancel some stuff out. So this is going to be plus 9 underneath. So we'll have 9 and 12 cancel in such a way that that becomes 3 and that becomes 4. So we're left with negative 8 over 3. Okay, so we can say that the gradient of the curve is negative 8 over 3 when x equals 3. Okay, so this is the answer to the question. Okay, so that's very simple little question here. Okay, just using the chain rule. So remember, anything in the denominator must be written in the numerator, any x terms in the denominator in the numerator. So this whole bracket, this whole thing can be written in the numerator as 1 bracket to the power of negative 1. Okay, and then you can differentiate this, multiply by the power, take one from the power, multiply by the differential of what's inside the function. So whenever you have something of this form, f of g of x, okay, if you want to differentiate this, you're going to differentiate the main function, and then you multiply by the differential of what's inside the function. This is like the chain rule. So you differentiate the main thing as normal, and then you multiply by the differential of the part that's inside that function, the function inside the function. So that concludes this question. Very short, simple question here from one of my Test Your Understandings. And other questions from this particular paper, if I do answer them, will be found in the playlist over here. Okay, the playlist for the Test Your Understanding that this is from will be in the, you can find that over here in this link over here. Other questions from the topic of differentiation from P1 can be found over here, and other questions from differentiation of P1 and 2 of, in fact, just you can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.